I think I'm up and running. Let's get this centered. All right, so this video is going to be about writing graphs. Let's write 4 graphs in under 60 seconds, given the picture of the graph. And let's look at the numerics. I don't think I'll look at the geometric aspects of each of these right now. But at the first day of the term, if you recall, one of our goals was to understand conversion. And we're starting to get to the point where I'm hoping you're starting to see the conceptual sides of the numerics, the actual numbers at work. All right, so our goal here is to write a linear function, and I really wish in Algebra 1 that that was never put in your head, y equals mx plus b. I wish you had never seen that, because people get a linear mindset, and it's hard to break. So it would have been much better if we had written linear functions based on change from a coordinate, quadratic functions based on change from a coordinate. Now, no point is more important than any other point on a line, so you could write the linear function from any point, but the numerics are governed from the vertex here, the vertex in the absolute value, and the endpoint of the square root function. All right, and we're going to do 3 or 4 of these in a row, and I hope after that practice, you can write all these functions in 4 functions in under 60 seconds. And if you can get it under 30 seconds, you're really flying. All right, so what have we learned so far? Well, this is a one-dimensional geometric shape, right? Whereas quadratic is a 4-sided figure, 2 dimensions to that, and it finds area. Absolute value is really linear branches. And the square root function is looking at the side of a square. That's what a square root is. And so there's geometry behind all of this. Now you can pause the video after, I'm just going to do all 4, and then you can look at the patterns, numerical patterns. So 4, 7, we want to highlight 4, 7, so subtraction. And then we got the marker, subtraction. And we got the marker, subtraction. And we're bringing in the number we want after we subtract out the number we don't want. And the same thing with the square root function. Now, you're probably at a stage where some people are graphing square roots going up like that, but that's the right-hand side of x squared. We're doing the inverse. So if you think of that as acceleration, then you can think of square root as something we could use for deceleration. Just pictorially. All right, so now it's just a question of division. Right? This is linear change. And so when I put the number 10 in, I get 6 units of linear change. This constant isn't changing. If you think it's changing and you see the number 7 change, please see me after tomorrow's class. We'll go up to the health center together. All right, so that's not changing. So all the change, numerical change taking place there. And when you drop a 10 in, it's not 6 units of change, it's 36 units of change. And you look at that long enough until you see the 36 units of change. Okay. When you drop a 10 in here, the absolute value of 10 minus 4 is just 6 units of change. When you drop in a 10 here, square root becomes the square root of 6. 10 minus 4 inside a square root, that's the change again. So right now we're adding the square root of 6 plus 7, we're looking at 6 plus 7, we're looking at 36 plus 7, we're looking at 6 plus 7, and we're trying to get to 50. That doesn't work, that doesn't work, that doesn't work, and that doesn't work. So what's the next way that you can get rid of things? Pause the video, think. If you said division, you'd be right. 6 doesn't work. 36 doesn't work. 6 doesn't work. Square root of 6 doesn't work. What works? What plus 7 takes you to 50? 43, 43, 43, 43. Now, to help you see a little bit of what's going on here, if you went from 4 to 10, you've gone over 6 units, but squaring it pushed you up 36. But you really wanted to go from 7 to 50 up 43. That's a ratio of change of 43 to 36. All right, so I'm going to give you new ones. We'll do one more of the positive when a is greater than 0. And so this is rise over run. This is rise over run squared as measured from the vertex. That's the A term. This is rise over the absolute value of run. And this is rise over the square root of run as measured from the endpoint. Just making a comment. When you do cubics, it's more complicated. All right. But still eminently doable. All right, so let's just get some lines and let's give it to you in tabular form. So let's say you got minus 5, 2, and you're going to go to 3, 29. So negative 5, 2 is the vertex. And you're going to go to 3, 29. Minus 5, 2 is for the absolute value. Absolute value is a V shape. Minus 5, 2 to 329. And the square root function in tabular form, minus 5, 2 is the endpoint. There's a domain restriction on this. And 329. And I'm going to erase the work here and just write the three answers. Linear, quadratic, absolute value, and square root. And by the time I erase, maybe you finished doing all of those. So you go ahead. All right. Conversion. I'm going to use subtraction. I'm going to subtract negative 5 out of the problem. Which gives me x plus 5. Now negative 5 plus 5, 0. I'm measuring. Usually rulers start at 0 yet. Then we measure things. Well, that means negative 5 is acting like that number right now. And I want to get 2, so I got that. So that means the quadratic. That means the absolute value. Very similar here in the square root. Okay. We got to get from 2 to 29. Got to get 27. Got to get 27 units of change. Got to get 27. Got to get 27 units of change. Okay, which means that the only way I get 29 here is to cancel that out. The only way I get 29 is to cancel that, and to cancel that. The question is, what do we get in those cancellation areas when I put a 3 in? Well, 3 plus 5 is 8. 3 plus 5 squared is 64. 3 plus 5 absolute value is 8. And over here, 3 plus 5 inside the square root is the square root of 8. Okay, so if you put that in Desmos, you're going to get the shapes and you're going to get the actual pictures of what we're putting on the board at the moment. You can come in. I'm just going to talk for another 5 minutes here. And you feel free, if you don't want to listen to it, that's fine. But I'm just finishing up the video. All right, so we're going to do one more. This time we're going to do quadratics, linear in the negative direction. Pick some random values. Okay, so we're looking at that. Some random values, absolute value, looking at this. Random values and square root. That's a negative square root. All right, and I'm going to put those values in, and your goal is to give me the equations in under 40 seconds. All right, under 40 seconds. Yeah, I shouldn't have to list that that's linear, quadratic, absolute value, and square root. You've had enough practice now that that should be the case. So let me get some random values. Negative 2, 9. This y value has to be smaller than 9. Let's go to 3, negative 2. No, I already showed negative 2. How about we do negative 4? Okay, so over here, negative 2, 9. I'll fill these in. You can write your equations, and hopefully you're done. Hopefully you're done by the time I get back, and I'm just going to do it quickly. Okay, everything can be seen. 3, negative 4. Over here, negative 2, 9. And 3, negative 4. And I'll do a challenge for you. Let's say we have negative 2, 9, but we send it in the other direction. And let's get it to be about negative 7, bigger than 9, 23. All right, so tomorrow, if you look at this video and you think about this as a challenge question, I'll leave that on the board and I'll just show you how to do it. Somebody will probably erase it, so I'll put it here as well. So let's see. -29, be interesting if anybody actually asks me to write that for them. But it'd be great if you could find it yourself. Okay, so that's on a board that won't get erased. I'll put it over here. Better. Coming back to the video. All right, so hopefully you had time to write all four. So I'm just gonna write those equations right now. Then we're done. So subtracting that out, x plus 2 gets to be 9. When I write that, I drop in a 3, 5 units of change, but I want to get to -4, which is down 13. Quadratic, x plus 2 squared. When I drop a 3 in there, I get 25 units. That's what's going to get kicked out. We got the 9 and the same thing, -13. Over here, absolute value. So we got x plus 2. When I put a 3 in there, I get 5 units of change. I want the 9, and I got to go down 13. Over here, I've got the square root of x plus 2 plus 9. When I drop a 3 in there, I get the square root of 5 units of change, which when I add to 9 does not take me to -4. How do I get from 9 to -4 down 13? Okay, if you keep thinking about those, you should be able to do those quickly and easily, certainly all four in under 40 seconds. Maybe not today, maybe not tomorrow, but by midterm, if you're working, I see no reason why you can't do that. All right, so let me stop the video. I'll post that on Canvas and hopefully you do spend some time with it until you feel like, oh, I own that.